In this video, we're going to walk through two examples of the law of sines. It's the only method we have so far for working with triangles that are not necessarily right triangles. So both of the examples you can see here are not right triangles as far as we know. So in example number one, we're going to look for the pair of angle with the side that is across from it. And so here we have the 50-degree angle across from the 27 side. And so our first fraction is going to be the sine of 50 divided by the 27. The other pair is going to involve our unknown. We're going to have the x across from the 30. So we'll have the sine of x over 30. Notice how the angles are always on the top of the fractions with the sign, and the sides, the 30 and the 27, are always in the denominators of the fraction, as I've highlighted here. So the first thing I'm going to do is I'm going to solve for the sine of 50. The sine of 50 is 0.766. So we have 0.766 over 27 equals the sine of x over 30. Again, we'll cross multiply, and I say again because this is a procedure we've done many times before. And I'll have 27 times the sine of x equals, and then 30 times 0.766, which is 22.98. We'll divide by 27 to cancel on this side, divide by 27, and we'll have the sine of x equals 0.8512. And so the last thing we need to do here in order to get the x by itself is take the inverse sine of both sides. That'll cancel the signs over here. And we'll be left with x equals the inverse sine of 0.8511, or 8512, excuse me. And we get 58.3 degrees. And so we have solved for x in the above diagram. And now that we know that x is 58.3 degrees, we could certainly solve for our missing angle down here because the triangle has to add up to 180, and then we could solve for the opposite side. And I'll leave that to you to work through. The problem on the right here is a little bit different because we're solving for a side instead of one of the angles. And so here we can look at the x as the thing that we're trying to solve for. Our first pair of angle and side across from it is going to be this 118 and the 31 that you see marked here. So my first fraction will be the sine of 118 over 31. The second pair is going to be the 20-degree angle here, which is opposite of the x, the thing that we're trying to solve for. So we'll write the sine of 20 over x. Here, I can actually do the sine of 118 on the calculator and the sine of 20 on the calculator. So I'll turn both of those into decimals right now. I have the sine of 118 is 0.883. So 0.883 over 31 equals. And the sine of 20 I have is 0.342 over x. And we can see here this problem is almost going to be easier than the last one because when we cross multiply and then divide, the x will already be by itself. There won't be any reason for inverse trig here. So 31 times 0.342 is going to be 10.6. So we'll have 10.6 equals 0.883x. We'll divide by 0.883 on both sides. And we'll have x equals divided by 0.883, 12, almost on the dot. So x here will be 12. Now again, we could solve for this missing angle here because triangles have to add up to 180, and then set up the law of sines if we wanted to solve for this remaining side.